Ooh yeah, this is Pick Computing A-Level Computing video number 21, looking at the octal number system. So to help us understand octal, we need to remember about our normal number system, decimal or denary, which is base 10, and we should remember from the last video how we arrive at answers in decimal and the base 10 number system. Octal is base 8. Okay, where has it been used? Well, it was used originally in ancient times by the first Native Americans, and nowadays might be used in file permissions on Unix systems. Another thing that we need to remember from previous videos is that with binary, digits could only be either a 0 or a 1. Now it's different in octal because octal digits could be 0 through to 7. So it could be 0, 1, 2, 3, 4, 5, 6 or 7. We want a similar layout in table for when calculating between octal and denary. And instead of a base 10 number system or a base 2 number system as it is in binary, we need to use the base 8 number system. So if we actually work those out, there will be those values. And if we took a octal value such as 157106, we'd write it in under the appropriate column, and then we do a bit of multiplication just like we did with binary, but the multiplication is going to be more complicated. This one obviously is 6. 8 times 0 is going to be 0. 1 times 64 is pretty easy, 64. But as the numbers get bigger, and because these aren't all just 1s or 0s, they can be anything between 0 and 7, the math is a bit harder. So 7 times 5, 112 is that, and so on and so forth. So we add all those up together to get our denary answer. So those are quite big numbers. In an exam, you're less likely to be asked about octal to denary conversions with such big octal numbers in the first place. So I've just given you a hard one there, and you should be able to try out some easier ones. There are some for you to try out. Number 10 is in red, and that's because you wouldn't be able to do number 10. Can you spot why? Pause the video and have a go at these for yourself. When we come to converting the other way around from denary to octal, let's take a look at an example. So if we took the decimal value of 93, what we do first of all is divide it by 8. And when we divide 93 by 8, we get 11, remainder 5. And because we get remainder 5, we use that as the right-hand most digit of our octal equivalent of 93. Then we do the first value divided by 8 again, and we get 1 remainder 3. So we use the 3 as part of our octal value as well. When we do 1 divided by 8, we actually get a number that is less than 1. And when we do that, it means that you use the number that you divided by 8 for the last time. So we use that at the front. So 93 in octal is 135. Let's just try another. So say we took 4023, the decimal value, divide it by 8, we get 502, remainder 7. 502 divided by 8 is 62, remainder 6. 62 divided by 8 is 7, remainder 6. And 7 divided by 8 is less than 1, so we use the 7 at the front to get 7667. Try these for yourself. If you're having a go at those and you were unsure as to what to do if you had a remainder 0 at any point, well, let's have a look at that now. So if you had a denary value of 199, 199 divided by 8 is 24, remainder 7, so we use the 7 as part of our octal equivalent. 24 divided by 8 is 3, remainder 0. Now, if you get 0 then as a remainder, then you have to use it as part of the equivalent in octal. Now, that was something I wasn't sure about when I first looked at decimal to octal, but there we go. Then you have 3 divided by 8 is less than 1, so we know that if the value of the division is less than 1, then we use the 3 at the front. So rules of deanery to octal, if the remainder is 0 or more, then use the remainder at the next most right-hand position in the result, and that includes if the remainder is 0. If the dividend divided by the divisor is less than 1, then use the dividend at the next most right-hand position in the result. One other thing you might get asked about in an exam might be the relationship between octal values and binary values. If we had a 9-bit binary value, such as this one, 101, 001, 110, what we can do to convert it into octal is split it up into sections of 3 bits. So let's just basically divide it up into 3. Now if we convert 101 from binary to decimal, we get 5. 001 would be 1, and 110, as we know, will be the 4 and the 2, 6. Now that's these values, these sets of 3 bits, converted to decimal. 101, 001, 110 converted to decimal is actually 334. And if we took 334 and converted it into octal, we actually get 500, so we get 516. So there is a relationship there, and the relationship's main thing to think about is the fact that if you split up binary values into groups of 3, then they can be converted into octal numbers very easily. By the way, if you didn't have multiples of 3, so here I've got 7 bits in this binary number, to be able to do the same thing, you would just need to pad it out at the front with some leading zeros. So we've got 9 there now, and then you can split it up into groups of 3. So that should be easy enough for you to do. Try these for yourself, and thanks for watching.